This video will demonstrate how graphing apps can be used by students to investigate mathematical ideas. Graphing apps can provide a powerful tool for encouraging students in the use of technology. Students have ownership of the mathematics and the process of constructing the mathematical objects. The app aids the process of students constructing their own understanding of mathematical relationships. Here, you will see students guided through a task on investigating graph transformations using a graphing app on their smartphones.
We're going to start with f of x equals x squared. Important, you got it as a function here. Right, we're now going to plot the transformed function g of x equals f of x plus a plus b. We're going to add sliders for our parameters, and we can then move around these sliders to our heart's content. Turn to the person next to you and describe how A and B affect the transformation on the graph.
So as A gets more negative, it moves further to the right, and as it gets more positive, it moves further to the left.
So it's just horizontal translation. Well, A is horizontal, B is vertical.
But then for A, it's translated by minus A, the x value.
What's happening as we move A and B?
So as you increase B, the whole graph moves up to the translation.
Oh, two things there. So as we increase B, it moves up. There was one other word that was really important in that, which was?
Translation.
Translation, brilliant. So as B goes up, it moves the graph up. Any other suggestions then relating to A? Yeah?
A just moves the graph horizontally instead of vertically like B does.
Anyone want to say how it moves it?
If you increase A, it will move towards the left, but if you decrease A, then it will move towards the right.
As I increase A, it moves it to the left. It moves it to a more negative x value. I'd like you now to try putting a couple of different functions in there, and then either using your mini whiteboards or talking to the person next to you, can you explain why changing B moves it positively in the y, but changing A moves it negatively in the x?
If you increase A, then it would go to the left because it needs to be more negative to be 0, like the y-intercept.
Does that work for all graphs?
Only ones that touch the x-axis.
We've got this graph here, and we can see the three roots at -2, 0 and 2. If I put 2 into the function, the value is 0. Why then has this moved from 2 to -3 when I've done f of x plus 5, f of x plus a?
Because you can put -3 into g of x and it'll be 0.
Because if we've started with -3, why have we ended up with this point and so a 0?
You just add 5.
You add 5. So if I add 5 to -3, I get to 2, and then I put that into my function, and when I put 2 into my function, then I know I'll get a 0 out of there. This morning I went through the activity with your students using Desmos on their phones and doing the graphs transformations.
Mm-hmm.
What are your reflections on that?
Oh, I thought it was wonderful. I really want to get more into that software and learn how to use it. The students adapted to it immensely quickly. They were very confident using it on their phones with minimum of preparation, and it showed exactly what you wanted them to see.
What do you think it added that the students had the graph on a device in their hand that they could manipulate?
Well, as I think some of them said, it took all the drudgery out of it. Rather than having to plot a graph or even just sketch a graph on a piece of paper and then move it about by plotting new points or whatever, they could actually move the graph just by moving a slider and seeing which way the graph went. They were actually doing it for themselves and coming to their own conclusions and discussing their conclusions with each other before you did it on the board.
I think there's an element in terms of they're so familiar with their phones and they take to the software so well that the sort of investigative approach to maths, the asking the what if type questions, just comes much more naturally when they can ask and answer the what if questions themselves because they've got a device in front of them.
And it doesn't have to be within the classroom.
How realistic do you think that is to use phones in the classroom?
That'll be up to a school's policy. It's certainly something that should be discussed at senior leadership level, but my eyes have been opened by this activity and I would be very keen for students to use phones responsibly in these situations.